All right, hello again. So today is super similar to yesterday, except for it's going to be exponential decay instead of exponential growth. Um, but everything is the same. There's our equation. Um, in just yesterday, we would have had a problem like this, and we had plus something instead of minus something. Okay, and so it does the same thing. What's the initial amount? What's the rate? Okay, so 0.35. Oop, that's a 55, not a 35. 0.35. So that would be 35%. And then instead of yesterday, it said evaluate when t equals 5, and then today's it'll say evaluate when t equals 3. So you have to do 1 minus 0.35, and again, use a calculator. That's fine. I mean, I'm not expecting you to go crazy and do everything by hand. And then for sure, doing decimals to an exponent, that would be crazy to do by hand. So 0.65 to the third power, 0.27. You can round it off. It was 0.274, so 0.27. 0.27 times 300, and we actually get 81. Okay, so there's not anything different other than minus instead of plus. Okay, so if you had a problem like this, so it wants to know the initial amount. That should always be the easy one, just that number in the front, 1,350. And then for the rate, and when it's combined like that, like so it's 0.85, this one was 1 minus 0.35. So when you do 1 minus 3.5, you get like that 0.65. And so on this one, when it's already combined like that, you can just do 1 minus 0.85, and you get 0.15, which is 15%. Okay, so just do 1 minus whatever that is, and you'll get the actual rate. Okay? And then you kind of go back to what it was, 1,350 times 0.85, and then 3 to do the evaluating part. Okay, so 0.85 to the third power is 0.61 times 1350, and we get 829.1. So all your answers today, if you do them correctly, will be smaller than that initial number. So we had 3 at the beginning, and then it went all the way down to 81, and then this one was 1,350, and then went down to 829. Okay, and so this one went, the first one went down by a lot more because the rate, 35%, is a lot higher. than 15%. So it'll go down, just not as fast. Okay, so just remember that, you know, if you saw, I'm not going to do like the whole problem on these, but if you saw, let's say like 0.94, and I'm only talking about the rate on these ones. So you would do 1 minus 0.94, and you would get 0.06, which is 6%. So remember, we move that decimal 2 spaces to the right. Okay, if we had just 0.8, okay, for the rate you would do 1 minus 0.8 is 0.2, and that is 20%, because again, let me rewrite that part. 0.2, you go 1, 2 spaces, and there's a part that's missing, so you need to add that in. Okay, so 0.0 something, that's when you're going to have 1%, 2%, 3%, where there's that 0 in the front. 0.2, 0.3, 0.4, 0.5, that's like 20, 30, 40, 50. Okay, so just be careful of that. All right, and then you'll have somewhere you need to write a exponential decay based on a situation. So let's see, a $25,000 car decreases 8% each year. Okay, so here's our initial amount. Then you'd have 1 minus 0.08. Okay, so remember that single digit for the rate part, 8%, to write that as a decimal, you know, so really the decimal is like after the 8. And we go 1, 2 to the left, and we get 0.08. So any single digit percent, 1%, 2%, all the way up to 9%, is 0.0 whatever, 0.07, 0.03. Okay, but then you do want to combine, like, and you can use a calculator, do that together. 0.92. And that would be your complete answer. Okay, so everything's the same as yesterday except minus instead of plus. Okay, and then tomorrow we'll start to look at some situations on like how do you know if it's exponential growth versus decay, and some of it you could probably figure out is what we talked about now, but we'll kind of combine some stuff together. Okay, all right, hope you're doing good. Have a great day, and we'll see you tomorrow.